Alrighty, we're moving right along here to section 1.4, and that is quadratic equations and applications. So in this section, you're going to study 4 methods to solve quadratic equations. Factoring, extracting square roots, completing the square, and then finally the quadratic formula. Basically, it boils down to 2 methods here. 1, get every term on the left-hand side of the equation, so we set the whole thing equal to 0, and then we factor it and set each factor to 0. And the second method might be to isolate the squared term and then square root each side. So this first method, get everything on the left side, set it equal to 0, and then factor. This applies when you have a squared term and then you're either going to add or subtract a term with an x in it. You need an x squared and an x, and then you're going to get everything on one side, set it equal to 0, and factor it. This second one, isolate the squared term and then square root each side. That's only going to work when you have the x squared term. You cannot have another x term, x to the first power. And you'll see this in the next couple examples. So factoring, a quadratic equation in variable x is an equation that can be written in this general form. We're going to have some number x squared plus or minus some other number bx, and then plus or minus some constant c, and that's going to be set equal to 0. That is our quadratic equation. And I always thought, quad means 4. I always thought it was odd that there was a second power was your highest power in a quadratic equation. But here in example 1, solve a quadratic equation by factoring. And I look at this and I have a squared term and I have an x term, so I know I'm going to get everything on one side, set it equal to 0, and factor. So to do that, I need to get rid of this positive 3 over here. I'm going to subtract 3 from both sides. So now I have 2x squared plus 9x plus 4 is equal to 0. And now that I got it equal to 0, I can factor it, just like we did at the end of chapter P. So here my factors turn out to be 2x plus 1 and an x plus 4, and that is equal to 0. And there is something, I can't remember if this book explicitly states it, but we have the zero product property. That says if we multiply two things, like a times b, and the answer is 0, that means either the first thing is 0, a, because 0 times anything b would equal 0, or the second thing is 0, b, because a times something 0 is equal to 0, or maybe they're both equal to 0. And that's just what we have here. This first term multiplied by this second term is equal to 0. So we can be suspicious that one or the other or both are equal to 0. So we're going to look at them independently. I'm going to take the first term, 2x plus 1, and set that equal to 0. And then I subtract 1 from each side, 2x equals negative 1, and then I divide by 2, x equals negative a half. And then we also check this other possible solution, x plus 4, the second factor. We set that equal to 0, and we solve for x by subtracting 4 from each side, and we get x equals negative 4. There are two numbers, negative a half and negative 4. If I plug them in place of these x's and compute the rest of the equation, it will be equal to 3. So we got everything on one side, set it equal to 0, and factor. Set each factor to 0. Now here we have another one, 6x squared minus 3x, and there is no constant. So we're not going to be able to factor it like we did that one, where we're going to have two binomial terms multiplied together, but we can still factor this. I look at each term here, 6x squared and 3x, and I realize that I can factor out a 3, and I can factor out an x. So that would leave in the parentheses, 3x times what is 6x squared? Well, that's got to be a 2x. And then minus 3x times what is 3x? Well, that's got to be a 1. And that is equal to 0. Now, in the first example, we had a binomial times a binomial. Now it's, we got this single term times a binomial. But the idea is still the same. We're going to set each term to 0. First, we set 3x equal to 0. We divide by 3, and we get x is 0. And then we take the second term. 2x minus 1 equals 0. We add 1 to both sides and get 2x is equal to 1. Divide by 2, x is a half. So there are two numbers, 0 or 1/2. If I stick them in for the x and this x and work the rest of that out, it will equal 0. So set the whole thing equal to 0 and factor it. Now we have this other method called extracting square roots. So here we're going to have only an x squared term. We need an x squared term, no x to the first power. So here in part A, 4x squared equals 12. The first thing I'm going to do is get x squared alone. So I'm going to divide by 4. And those 4's will cancel, and we'll have x squared equals 12 divided by 4 is 3. Now we have just this squared thing equal to 3. And we know how to get rid of a squared. We take the square root. Take the square root of each side. So this square and square root will cancel. We'll have x equals. And don't forget, when we are extracting these square roots, we've got to account for the positive and negative possibility, plus or minus the square root of 3. Because if we go back to the original equation, and we have our 4 and then something squared equals 12, I could put in the negative square root of 3. Because negative root 3 times negative root 3 would be positive 3, and 3 times 4 is 12. Or I could stick in that positive square root of 3, and a positive square root of 3 times a positive square root of 3 is 3, times 4 is 12. So don't forget to account for the positive and negative root there. Now letter B is a little different. We already have our squared term isolated. Remember, if something's in parentheses or a grouping symbol like this, that is taken together as a quantity. So we do have something over here, quantity squared, equal to 7. So just like we did in part A, we're just going to square root both sides. If I square root this side, the square and square root cancel, and I'm left with x minus 3. And then I would also square root this side with the 7 on it. And we would get plus or minus the square root of 7. And then to solve for x, I'm going to add 3 to get rid of this minus 3. So if we add 3 to both sides, we get x equals 3 plus or minus the square root of 7. And this actually, this plus minus sign here means there are two solutions. We could first use the plus sign. 3 plus the root of 7 is one answer. And then we could do it again with the minus sign. 3 minus the root of 7 is our other answer. So there are two solutions based on that plus minus. And now we move on to completing the square. This is just like a little formula, a little set of steps to follow that you can factor any quadratic at all, even if it doesn't have real solutions. So to complete the square for the expression x squared plus b times x, we add b divided by 2 squared, which is the square of the half of the coefficient of x. Consequently, x squared plus bx, we have this half b quantity squared, is equal to x plus b over 2, that quantity also squared. I'm sure I thoroughly confused you on that one. Actually, I'll just show you how to use this. And when we start plugging in numbers, you're going to see it's just a series of steps, simple steps that you follow, like a little algorithm. And you'll be able to factor any quadratic that you want. So in example 3, now we're going to start with the easiest type. The leading coefficient is 1. So in front of this x squared is a 1. We don't write it there. It is implied. But I'm just going to copy it down here. X squared plus 2x minus 6 is equal to 0. So if we try to think about factoring this, the old way, we got our x, and x is going to equal x squared. The factors of minus 6 that add up to positive 2. We could figure out the factors of 6 are 1 and 6, and 2 times 3. And there's no way we can combine those together with positive and negative signs that are going to get us to a plus 2 for our middle term. So how we've factored in the past with this is not going to work. But there is a way to make this work. What I'm going to do is, I'm not going to really change much. I'm going to move this minus 6 to the other side. I'm going to add 6 to both sides. And when I rewrite my equation, I'm going to leave a little space there. X squared plus 2x. I'm going to leave a gap. And now we're equal to, over here we had a 0 and we added 6 to both sides. So now there's a 6 on this side. Now, we want to plug a number here. And let me even do it this way. Squared. We're going to plug in a number right here that is going to turn this into a perfect squared trinomial. So we'll be able to factor it as x, plus some number, quantity squared. And the trick is to figure out what number goes here that's going to make that happen. What we want to do is take this number in front of the x, take this number, cut it in half of this number, and then square it. and then we want to do quantity squared, and that number is going to go right here. And this is kind of a too easy of an example because here our coefficient in front of x is 2. We chop that in half, that's a 1. We square 1. 1 squared is 1. And of course, if we add 1 to this left side of the equal sign, we're going to have to add 1 over here to make it fair. So, when we think about this now as a perfect squared trinomial, this is going to be x plus 1 quantity squared. If we FOIL that out, our middle term would be 2x. Over here on the right, we got 6 plus 1, that is equal to 7. And now we have something perfectly squared equal to this number. So we can do our extraction of roots. We're going to square root this side, and we're going to square root this side, and don't forget the plus or minus. So when we take this square root, we get what is under the radical. The square and the square root cancel. So now we just have x plus 1 is equal to positive or negative square root of 7. And we're going to solve for x, so we're going to subtract 1. Oops, didn't mean to do that. Okay, we're solving for x, so we're going to subtract 1 from each side. I'm going to subtract that 1 out of there. Now it's x equals negative 1 plus or minus the square root of 7. Again, that plus or minus means two separate solutions. Negative 1 plus the root of 7, and again with negative 1 minus the root of 7. So again, the idea is, we're focusing in on that number in front of the x. We're going to take that number, cut it in half, and then square it. And you'll see, again, that first example was kind of too easy because it turned out to be a 1. You'll see some where we get a little more complicated number in there and even a fraction. So example 4, now we change it up a little bit, and our leading coefficient is not 1. Now we have a 2 there. So the first thing we want to do is get that leading coefficient to be a 1. And we are just going to do that by dividing every term through by 2. Here we have a leading coefficient of 2. I have to divide every term by 2. Even the 0. So now these 2's cancel, and we have x squared plus 8 divided by 2 is 4. That come out to be a nice whole number. That'll make that a little easier. And then we have plus 3 halves, and now that's equal to 0 divided by 2 is 0. And to get ready to perform the completing the square, remember I want to get that 3 halves out of there. So I'm going to leave an open space here. I'm going to have equals. When I move that 3 halves over to the other side, it changes to a negative 3 halves. We subtracted it from both sides. And now we're set up and ready to do our completing the square. So I'm going to move this up. Again, the end game is to have something down here, a quantity perfectly squared, equal to, and we just got to figure out what number goes here is going to make that happen perfectly. So concentrate on the number in front of x. Here it's a 4. We want to cut that in half and then square the result. So if we take 4 and chop it in half, we get a 2, and we square 2. 2 squared is 4. So we're also going to add 4 to this side. Alrighty. So when we come up with our perfect square binomial here, it's going to be x plus 2 quantity squared. If we FOIL that out, our middle term would be a 4x. Our last coefficient would be a plus 4. And let's see what we got over here on this side. We have our negative 3 halves plus, we're going to change 4 into halves. So we're going to multiply the numerator and denominator by a 2, and we get 8 halves. So 8 halves plus a negative 3 halves, or 8 halves minus 3 halves, is 5 halves. Alrighty. Now we're ready to square root both sides. So over here we have our quantity perfectly squared. The square root will cancel with that, and we're left with just the x plus 2 equal to, and we would square root our fraction, 5 halves, and don't forget we have plus or minus. And we are solving for x, so we're going to get that plus 2 away from there. We're just going to subtract that from both sides. So x equals, this was a plus 2, we're going to subtract from both sides. Now it's a minus 2, and then plus or minus the square root of 5 halves. And I guess we can leave it just like that. Maybe rationalize that denominator, but that's good enough, and I believe that's exactly how the book leaves that example. All right, now example 5. Again, we're completing the square, leading coefficient not 1. But you're going to see we're going to get into a little bit more fraction action here. So we want to get that leading coefficient to be a 1. We're going to divide everything by 3. So those are going to cancel, and we're going to have our x squared minus 4/3 x minus 5/3 is equal to 0. And then I'm going to get that minus 5/3 out of there. I'm going to move it to the other side, make it a positive, add it to both sides. So that's x squared minus 4/3 x minus, don't need that, I'm moving that over to the other side. Now over here it is a positive 5/3. So now might be the part that some people aren't going to like. Remember, we got to take this number in front of x and chop it in half. And after we chop it in half, we square it, and it goes right here. And actually the number we put here isn't really that important, because we're more worried about what comes down in here, equal to. So how do you cut a fraction in half? Well, we double the denominator. If we take, let me come up here and do a little scratch work. That is 4/3. If we cut that in half, we multiply it by 1/2. So all we're really doing is the numerator stays the same, 4. The denominator has been doubled to a 6. And 4/6 is going to reduce down to a 2/3. So if we take this number and we chop it in half, we can drop that number right down here into these parentheses. We're going to have x minus, if we take 4/3, double the denominator, it becomes 4/6, and 4/6 reduces to 2/3. Now, when we remember, we got to put that number here and square it and add that to both sides. So 2/3 squared is going to be 2/3 squared is just going to be 4/9. So we're going to add 4/9 to this side, and we're going to add 4/9 to this side. And we do need a common denominator. To get this denominator to match, I'd multiply by a 3, multiply the numerator by a 3. So this is really 15/9. I'll scratch it out here and rewrite this as 15/9. And if we add those together, 15/9 plus 4/9 is 19/9. There we go. So probably the worst of it's over. Now we're just ready to extract our roots. On the left we have a quantity squared. We're just going to square root both sides and figure out our two solutions. So square rooting this left side, square and square root cancel, and we have x minus 2/3 equal to, this one I noticed the denominator is a perfect square. So we can square root the numerator and denominator separately. So when we do that, the square root, and we would only need one set of those plus minuses. When we take the square root of 9, that's a nice even 3. And in our numerator, we'll have plus or minus the root of 19. Ooh, and I like this because our denominators are already common, 3 on both of them. So to get x by itself, we're going to take this minus 2/3 out. We're going to move it over here and make it a plus 2/3, adding that to both sides. And now we have x equals, and let's put our 2 first, 2 plus or minus the root of 19 divided by 3. And I believe that is the last example. Again, completing the square, get your leading coefficient to be a 1. Find the number in front of your middle variable, usually it's an x variable. Chop that number in half. You can drop that right down into the parentheses of the binomial squared. And then square it to get the number that you add to both sides of the equation. So now it's time for you to do a little practice on your own. Ooh, looks like stuff got a little messy here. Let's see. Why do I have two number 41s? That's it, 41. Oops. Okay, I did lose one of my problems somewhere off the margin, but I did write it in there, number 47 on the team huddle. Quadratic equation by completing the square, 2x squared plus 5x minus 8. So pause the video, try the problems, come back and see if you got them right. All right, the first one, solve the quadratic equation by factoring. So when it does say solve, we want, x equals this number and that number. So we want to set this equal to 0 and factor it. I got a plus 12 on the right side of the equals. I'm going to subtract that from both sides. I'm going to move it over and make it negative. So now we have x squared plus 4x minus 12 is equal to 0. And if I think about the factors of minus 12, I know this has got to be x and x. My signs, I have one of each, so there's going to be one plus and one minus. And the factors of 12. 1 and 12, 2 and 6, 3 and 4. The only two of these that are 4 apart on the number line would be 2 and 6. And my result is positive, so I want a plus 6 and a minus 2. And remember, that's equal to 0. When we were factoring in chapter P, that's where we'd stop. Now we have this equal to 0, so we can actually finish it off and solve it. So set the first factor equal to 0. X plus 6 equals 0 means x is negative 6. Second factor, x minus 2 is equal to 0 means x is equal to 2. So there are two solutions to our first quadratic equation. So we can move this up out of the way. Oops. The next one, 27, solve the equation by extracting square roots. And here we only have an x squared term. There is no x term. So the easy way to do these are get the x squared term alone, and it already is. You know, the leading coefficient is 1. So right here we can square root both sides. The square root of x squared is x, and that's equal to, don't forget, plus or minus the root of 11. Oops. Number 41, we're on to complete the square. And this is the basic one, leading coefficient of 1. So we're all ready to go. That leading coefficient is 1. I'm going to rewrite this, moving that 2 out of the way. We have our x squared plus 6x, leave a little space. Now we're going to move that 2 over. Here it's a positive 2. Over here it's a negative 2. And we want to figure out, you know, what is going to be our binomial perfectly squared. So what's going to go x plus, you know, just bring down your x, bring down your plus. What goes here, and whatever goes here, we square it and move it back up here. So in front of the x is a 6. We chop that in half. That's going to come right down here. Half of 6 is 3. To figure out what we add to each side, we bounce it back up and square it. So here we're going to have a 3 squared is 9. We're going to add 9 to this side. So 9 minus 2, or negative 2 plus 9, is 7. And now we're all ready to extract the roots. On the left side we have a quantity squared, which we can eliminate with a square root. Those cancel. X plus 3 is equal to, we take the square root of 7, and don't forget our positive and negative roots. And then of course we're solving for x, so I want to get this positive 3 out of there. I'm going to move it to the other side, make it negative. X equals negative 3, plus or minus the square root of 7. And those are two distinct solutions, negative 3 plus root 7 and negative 3 minus root 7. Alright, and the last one here is a little more complicated, completing the square. The leading coefficient is greater than 1. So that's the first step we're going to have to take. You know, our leading coefficient is 2. We're going to divide that leading term by 2, the middle term by 2, the last constant by 2, and even, you know, we're dividing that 0 by 2 also. So these cancel now, and we have x squared plus 5 halves x minus 4. And let's move that minus 4 over right now. That would be a minus 4 here. Move it to the other side. It becomes a plus 4. And now let's get ready to do our completing the square. So down here, we're going to have a perfect binomial squared. And you know our first term is going to be an x, and this sign's a plus, so it's got to be a plus. And that's equal to, we'll have our 4 over here. So we chop this number in half and bring it down. And remember, that's as easy as double the denominator. Numerator stays the same, 5. Denominator doubles to a 4. Now to find out what we add to both sides, we square this. Just do numerator and denominator separately. Numerator is 5, 5 squared is 25. Denominator 4, 4 squared is 16. So I'm also going to add that to this side, 25 sixteenths. And as we bring this down here, let's get a common denominator. This is 4 over 1. So we need the numerator. You know, if we multiply this denominator by 16, we multiply the numerator by 16. Let's see, 16 times 4 is 64 sixteenths plus 25 sixteenths. And if we add those together, 64 and 25 add up to 89 sixteenths. So we'll make that 89 sixteenths. When I like the denominator is a perfect square. So when we square root, you know, that denominator will come out real nice. And speaking of square rooting, let's square root right now. plus or minus. So we square root the left side and we get x plus 5/4. And that's equal to, our numerator is not a perfect square, so we'll leave that as plus or minus the root of 89, divided by the square root of 16 is the perfect square, 4. Oops. So the last step, we are solving for x, so we're going to get that 5/4 out of there. We're going to subtract it from both sides. So x equals, here it is a positive 5/4, bring it over, now it is a negative 5/4, and the common denominator is 4, it's already there, so we'll just plus or minus our root of 89 right after the 5. And a little trickier. But we have our two solutions, negative 5 plus the root of 89 over 4, or negative 5 minus the root of 89 over 4. And the homework for this, oops, what is this? Oh, that's the 47. That's the one I was missing. Aha, I just moved it to another page so I had more room to write. That's where it went. The assignment for this is section 1-4 in the book, day 1. That's on page 118. It looks like a lot of problems here. The upper level ones are the completing the square, but some of the earlier ones are, just factor or extract square roots. And those extracting square roots go pretty quick. So have fun with the homework.